The topic today we are going to discuss is electricity. We will be covering the following areas of scheme of work as you can see on the screen. At the end of this presentation, students will learn about electric charges, mechanism of Van de Graaff generator, electric sparks, types of electric circuits, the difference between conductors and insulators, some facts about batteries, how resistance affects on electric current, and comparison of series and parallel circuits. Electric charges, our first topic. Electric charge is a basic property of electricity which determines the charge. The term charge can be categorized into two types such as positive charges and negative charges. The positive charges are also known as protons and negative charges are called electrons. With respect to the presence of number of electrons and protons, objects can be divided into three groups such as neutral objects, negatively charged objects, and positively charged objects. As you can see in the first diagram, neutral objects consist equal number of protons and electrons. As in the second diagram, negatively charged objects consist more electrons compared to protons. Next, according to the third diagram, positively charged objects consist more positive charges, or we call them protons. Attraction and repulsion. First of all, we should clarify what are like charges and unlike charges. Simply remember, like charges refer to similar charges, whereas unlike charges refer to opposite charges. Accordingly, positive to positive and negative to negative are like charges, whereas positive to negative can be considered as unlike charges. So the main important point is like charges get repelled from each other, whereas unlike charges get attracted towards each other, which means they are getting closer. In addition to that, neutral objects neither show repulsion nor attraction. Static electricity. Static electricity can be defined as building up of electrical charges on the surface of an object. It's called static because the charges remain in one area rather than moving or flowing to another area. We can see static electricity every day. It can even build up on us as well. For example, rubbing a balloon on our hair, lightning, which is the commonest, combing clear dry hair, and after that we have an interesting topic which is Van de Graaff generator. This is an electrostatic machine which is capable of building up and storing charges. A Van de Graaff generator uses static electricity and a moving belt to charge a large metal sphere which is known as the dome. It is also shown in the diagram. As you can see, inside this generator a motor turns a silicon roller which makes a rubber belt starts to move. More and more charges build up on the dome until it reaches a high voltage. Observe what happens when the dome is touched by someone while it's switched on, as in the picture. So you can see, due to high voltage, the hair gets erected, as in the image. Electric sparks. Electricity is the flow of tiny particles called electrons and protons. It can also mean the energy you get when electrons flow from one place to another place. Electricity can be seen in the nature as a bolt of lightning. Lightning is nothing but a large number of electrons flowing through air all at once, releasing a huge amount of energy. So simply remember, lightning is electricity released from Earth's atmosphere during thunderstorms. Electric circuits. The pathway in which electricity can flow is known as electric circuit. In the diagram given, red color arrows show the pathway of flow of electricity. Ammeter is the instrument which is used to measure the amount of electric current in a circuit. Amps or amperes can be used as units to measure electric current. Next is about complete circuits and incomplete circuits. If you observe these two circuits carefully, you can see that due to presence of a gap, the first circuit is not completed. That's why we call it an incomplete circuit. But as you can see in this second circuit, it is entirely completed, or else we can say it's completely connected. Simply remember, incomplete circuits consist a gap, whereas complete circuits do not consist a gap as shown in this slide. Conductors and insulators. Before we discuss about conductors and insulators, let's see what this property is. Ability to pass electricity through an object is known as electrical conductivity. Materials can be divided into two groups as conductors and insulators based on their electrical conductivity. Conductors allow electricity to pass through, whereas insulators do not allow electricity to pass through. In this slide, we are going to learn some examples and functions of conductors and insulators. Conductors are mainly used for electrical conductivity purposes, such as metals and graphite. Graphite is actually a non-metal, but still it's a good conductor of electricity. Insulators are mainly used for our safety, such as glass, wood, plastic, paper, and non-metals except graphite. So that's why this wire which is given in the picture is insulated from rubber. This is an experiment which is conducted to identify conductors and insulators. So here we need a bulb, a battery, a substance to be tested, example iron nail, two crocodile clips and wires to connect these electrical components with each other. Using these electrical components, we can set the apparatus as shown in the diagram. Here the main point which I want to emphasize is the bulb will light up if the tested substance is a conductor only, whereas if the tested substance is an insulator, the bulb will not light up. Conductivity. In the textbook, page number 94, they have mentioned some substances along with their conductivities in numerical values. Accordingly, these substances can be arranged in descending order, which means highest to the lowest based on their electrical conductivities. Highest is silver. We know that silver is a good conductor as it's a metal. Then copper. After that aluminium, next steel, water, PVC, which means plastic, air, and the least is rubber, which is an insulator. Portable power packs. So here we are going to discuss about some batteries. A battery is made up of a collection of cells joined together. So here let's see what are the special characteristics of some types of cells. Dry cell. It is commonly used in electrical appliances nowadays. Its shape can be carried easily as it doesn't consist liquids to spill. Mercury cell, or else we call it even button cells. It is expensive even though it's small in size. Mercury cells are capable of producing either large currents for a short time or small currents for a long time. The lead acid cell. This is the cell which is commonly used in vehicles. It is rechargeable, heavy, and it consists liquids such as acids. The reserve cell. The reserve cell works when salt water is added only, and it produces high current for a short time or small current for a long time. The nickel-cadmium cell, which means it consists nickel and cadmium. It is expensive, rechargeable, completely sealed, and it's light in weight. The lithium cell, it is also another kind of a tiny cell. It's very small, reliable, expensive, and it lasts for a long time compared with other types of cells. Resistance, very important topic. Electric resistance can be defined as a barrier or an obstacle which causes flow of electricity to be decreased. Electrical resistance is measured by ohms as it is recognized internationally. Look at the picture which I have inserted in this slide. Can you see a small boy is trampling the hose? Simply what he wants to do is to block the waterway. The act done by the boy is equal to the action done by the resistance on a circuit, which is to reduce the flow of electricity. Since resistance is a barrier, it causes flow of electric current to be decreased due to obstructing the path of electricity. Resistance of a wire depends on two main factors, such as length of the wire and thickness of the wire. A long wire has high resistance compared to a short wire, which means when the length of the wire increases, its resistance too increases as they both are proportional with each other. The resistance of a thin wire is greater than the resistance of a thick wire. Therefore, when the thickness of a wire increases, its resistance decreases as they both are inversely proportional. Series and parallel circuits. Very first thing which we should clarify is the term series and parallel. Series means one after the other, whereas parallel means one below the other. Now look at the first circuit. There you can see the two bulbs are connected one after the other. So we call it a series circuit. Next, observe the second circuit. There you can see second bulb is connected below the first bulb. Since the first bulb is connected parallelly, we call it a parallel circuit. This concludes the focus of the presentation on electricity. I sincerely appreciate your interest and attention. Thank you so much.